Hello, I'll be describing a light and sound circuit which can be used for the B9 robot from the 1960s Lost in Space TV programme. This project is particularly suited to the Mobius 1/6 scale model kit, which is quite large, coming in at 33 centimeters height, that's 13 inches when fully completed. There have been extensive kit reviews done by others, so I won't go into the kit in too much detail itself. I'll be concentrating on the lights and sounds. Looking at the kit though, my first thought is there's plenty of room inside to certainly insert some electronics. If we look at the main torso, here's the main torso. As you can see, it's quite large, and there's certainly a large area in there where we can fit lots of electronics. Also, if we look at the leg bellows, that's quite large too, and there's some room there where we can also fit some electronics. I've actually put some relays in there, as these are quite bulky and they're heavy too, and we want to keep the weight as low down in the robot as we possibly can to increase the stability. So, having seen all that space, this led me to design and put together a prototype circuit which is now completed on a solderless breadboard, and here it is. Yes, it looks quite complicated with all those wires there, but that's the nature of solderless breadboards, I'm afraid. In this format, it can seem a bit strange, but the wiring will be tidied up when soldered onto an electronic circuit board. Personally, I've had no formal training in electronics beyond the basics of V equals IR, voltage equals current times resistance, and some idea of different components, which really is all that's needed for a project of this sort. We can follow up by reading some tutorials readily available on the internet in the case of where specific components might actually be used. So back to the circuit. It's based on 4.5 volts as a 3 AA battery pack fits nicely in the tread section. Here's a battery pack. There we go, 3 AA battery pack. And if we look at the tread section, here's the tread section. Battery pack would go in there. We would take that plate off, of course, and the battery pack would fit nicely in the tread section. So that was the start of the whole project, and that set the voltage at 4.5 volts, which seemed a reasonable choice, as there are plenty of 5 volt components and modules easily available, as this is a popular voltage for digital applications. Now though, I am having some problems, as it doesn't take long for the battery voltage to drop to 4 volts, powering all these components. There's something in the region of 40 to 45 LEDs, plus relays and other components, all need powering up. And more importantly, there are some big voltage drops across some of the integrated circuits, the IC chips, which I didn't really know about this when I started the project, but I found out since. And these take the voltages below a critical 3 volt threshold on certain parts of the circuit. So now I've switched to mains power using a breadboard power supply module, and that's that black thing now. If we zoom in, there we go. So this is the power supply module, and that gives us a constant 5 volts, which helps the circuits to operate very well. I'll probably include both power sources in the actual robot when I get to complete the electronics inside. I certainly would like to keep the batteries, as it is nice to have a working model without wires sticking out the back, but the mains input will be useful for extended use of light and sound. Okay, let's switch on. So we use the power supply module switch in this case, and we switch on. Not a lot happens, but a few things do happen. We can see some lights coming on at the top right hand side. These correspond to the chest button rows. There's one there and one there, and also the programming bay light is that will come on. I call this standby mode. That will come on, and that's equivalent to the LED shown on the power supply module, which is that LED there. That LED there. There we go. Another thing you'll notice is the relays have the green light supply voltage indicators on now. So these are the supply voltage indicators there. Let's zoom in on the relays. Right. So we've got two sets of relays. There's one set there, and that's the second set there. And these will be used to receive signals from a 4-channel wireless transmitter to control the light and sound functions. And here's the transmitter here. That's a 4-channel transmitter. We've got 4 buttons on it. Very simple, but that's all we really need for this project. In fact, it's ideal because one thing I noticed is what we can probably do is fit it in nicely into the other part of the tread section, so that can go in there, the opposite side to the batteries, and it certainly serves its purpose. The other thing that I should mention is, rather than having a switch, what I will do is I will use the kit scale power pack, which was an integral part of the robot. Here it is here. That's the power pack of the robot, and that slots into the torso on the side there. This was used extensively in the TV program. So what I will do is make contacts on the back of that, and as this is pushed into robot, it will make contact, i.e. switch the electronics on, and as I take it out, it will break contact, so that will switch the electronics off. Very much has happened in a lot of episodes. Okay, so from standby mode, let's hit button A on the transmitter, and this will power the robot up fully. So we hit button A on the transmitter. This will come on in 3 stages. First, the chest red light bar will go on. That will be immediate. Then after a delay, the chest button green bars will come on, and the red and green dial lights will begin to wig-wag, and the lower chest lights will begin to flash in a type of random pattern. As well as this, the eyes, which are white LEDs, will light up. So here we go. That's 1, that's 2, and then the third part, we see the top amber lights come on. I'll do that a bit later on. We'll go through that in more detail, and you can see the delays coming into operation, because that was quite a big part of the whole process. Let's zoom in on the amber top lights. Alright, that's there. We can see this consists of 3 1.8mm LEDs. That's 1, 2, 3. They will be the crown lights, and there are 7 3mm LEDs which I will feed into the brain finger lights. So these are the 3mm LEDs, and they will go into the brain finger lights. The way I will do that is using fibre optics. So let's come out of there. These are my fibre optics. I've got 1mm fibre optics and I've got 0.75mm fibre optics. I'm hoping I can use the 1mm fibre optics and that will still be to scale. Basically all we do is one end of the fibre optic goes on the end of the LED, and that transmits the light to the other end of the fibre optic, which will come out of the brain finger lights. So when I say brain finger lights, looking at the diagram, I'm talking about the brain finger lights up there, and the crown lights are up the top, which we can't see in the diagram. So the delay process was the red lights came on immediately, then after a delay the green lights came on, followed by the flashing chest lights and also the lights for the eyes as well, and after the final delay, that's when the amber brain lights came on. So that completes the light operations for now. As I say, I'll go more into the delays nearer the end. Now for the sound. If I hit button B on the transmitter, that's button B, we hear a robot sound clip.
I computed to be an ionic directional probe searching for receiving outlets.
And as you can see, we've got distinct flashing lights there as well. Unfortunately they're blue at the moment, so I will need to desolder these and fit orange LEDs in their place, but the good news is the module I bought works very well. There's no direct connection between the sound card and the blue flashing lights. It works solely on detecting the sound levels coming from the sound card. So I was very pleased with that. If I hit button B again, the robot repeats the last sound. So I go for button B. I'll just zoom in on the relays as well so you can see what the relays are doing. So button B.
I computed to be an ionic directional probe searching for receiving outlets.
And if we hit button C, we energize a different relay and the robot will voice a new sound clip. So let's go for button C, watch the relays.
That does not compute.
And we'll do button C again.
I am sorry, Will Robinson. I am afraid I goofed.
So button B operates the second relay. You saw the second relay energizing light came up, and button C operates the third relay. So the third relay energizing light came up when we hit that button. If we go for button C again, you'll see you'll hear a new sound clip.
You might be placing us all in deadly danger.
And if I hit button B, that will just repeat whatever the last sound clip was. So we'll do that now, and if you look at the relays,
You might be placing us all in deadly danger.
there can be up to 20 sound clips on this circuit, which is USB programmable, so we can add and delete sounds, and we can also move them around as we see fit. Finally, button D on the transmitter switches the light off and puts the robot back into standby mode. So we hit button D. Let's zoom out first. All the lights are still flashing, of course, as we would expect. And we hit button D. Here we go. And we're back into standby mode. So let's switch on again and we can see the delays in action. Right, press pressing button A, the red light comes on immediately, followed by the green and the flashing, and last but not least we get the top amber lights. They come on after a second delay. So we'll just do that again. So we're back into standby and switching on red, green, top amber. Also there's an onboard switch which will change the chest light flashing, which is pausing at the moment, and we can have that continuous, but that will disable the dialight wigwags, which was the case in some episodes anyway. Those dialights didn't always wigwag, sometimes they were on constantly. Right, the switch on the board, which we can zoom in on, you can just about see it in the tangle of wires. There we go. You can also see the voice activated LEDs there to the left. They're the voice activated LEDs, and this is the switch which I will be switching, and that will change the flashing sequence on the chest lights. It's trying to focus. There we go. Right. Okay, and you'll see what happens there as I operate the switch. There we go. As you can see, the flashing has become continuous and the red dialight stays on, but the green dialight just stays off. So I've got a little bit of work to do there, because I'd like the green dialight to stay on as well as the red. Finally, there's another adjustment that can be made. Well, there's a few more actually. The chest light flashing rate can be adjusted too. So we need a small screwdriver for that, and we do that by adjusting the pulse generator, which is at the top there. You can see the pulse generator is flashing away there. That's sending a pulse to other parts of the circuit, and that really determines how fast or how slow the flashing chest lights go. So I'll zoom back in on the flashing chest lights, which are there, and I'll make the adjustment to the pulse generator. Right, so first of all I'll slow them down. There we go, nice and slow. I can have them as fast or slow as I like. I can even have them stationary if I really want to, but there's not really much point to that. And then I can speed them up again. There we go, speeding up. That's probably about right there. But we can go faster than that, and we can go very fast if we want to. In fact, so fast they're continuously on. But let's slow it down again. Probably something like that is quite nice. Some other adjustments that I've incorporated into the system is using some variable resistors. These aren't actually wired in at the moment, but it'd be a simple job to do so. And the bottom two, these are the variable resistors, and the bottom row, that will affect the delays. There are two delays in the circuit, so just by adjusting them, putting our screwdriver in and adjusting the variable resistors, we can increase or decrease the delays that we see between the red lights coming on, between the red bar lights coming on and the green lights coming on, and the top ambers coming on. And the other, there's three more. I will incorporate three more variable resistors, and these will I can use these to adjust the lighting of the LEDs, so it's just increasing or decreasing the resistance that goes to the LEDs, so I can make them brighter or I can dull them down, and I've got 3 different parts of the circuit which I can adjust independently. So there'll be 3 different parts there, and they can all be adjusted. Right, to switch the robot, we've put the robot back into standby mode. It's not necessary, but I could just disconnect the power, but I like to put him in standby mode first. So there we go, that's in standby mode. And then to switch him off, we just use the switch on the power supply unit. There we go. At the moment you can still see the relays have got power voltage to them. We switch that off and the relays lose their power supply. In the case of the robot, again, to switch it off, as I mentioned, that would just be a case of pulling the power pack out. I won't have a switch. I think that's more in tune with the TV series. Okay, well, thanks for looking at my video. I hope you enjoyed seeing the design. What I would intend to do is make another video which will describe the individual components on the board and what they do. I really enjoyed making this project. It was great fun, and as I mentioned before, I just learnt the electronics I needed as I went along. So it's really not that complicated at all.